So our last skill and our last learning unit in general chemistry is about functional groups. So what exactly is a functional group? Well, we introduced this in our last skill, but remember it's a specific grouping of atoms, generally those atoms that contain heteroatoms, so non-carbon and hydrogen atoms, and they provide a molecule with specific physical and chemical properties. So why organic chemistry groups things by functional groups is molecules that have the same functional group tend to have similar physical properties and similar chemical reactivity. So the ending of a molecule's name, that's the suffix, that's the part at the end of it, often tells us the most important functional group present, and that's going to be important for getting information on properties. So for example, here are a whole bunch of 2-carbon molecules, and the suffix or their ending piece tells us the functional group that's present. So this is ethanol. That's what's in drinking alcohol. We can see that it has an alcohol functional group. Okay. Ethanoic acid, also called acetic acid, which you guys know is vinegar. This has a carboxylic acid. Ethylamine. Okay. This has an amine functional group. Some of these are pretty obvious by the suffix. Ethene. This has an alkene functional group. So right now there's going to be about 16 names of things that you need to be able to know, recognize, draw, and think about their chemical reactivity. And I know that's a lot. It's going to be just one lecture that's an overview here, but it's going to set you up so well to be successful in organic chemistry. So what are the kinds of functional group problems you're going to see? Well, I just kind of mentioned them. The first one is looking at a molecule and being able to identify or name the functional groups that you see there. What you want to do is look for anything that's not carbon and hydrogen. Look for those heteroatoms. Heteroatoms are always going to be part of a named functional group. Sometimes we're going to be looking for double bonds or triple bonds as well, because those are part of a functional group as well. So kind of beginning skill is learning how to identify and name functional groups that we see in a molecule that's already been drawn for us. Another kind of problem might be to draw a molecule that contains a certain functional group that satisfies criteria for the prompt to draw that molecule. Maybe it's a 5-carbon molecule that it has an alcohol functional group, right? We're going to be drawing these as skeletal structures, so building on our skill from last time, we always want to be drawing skeletal structures moving forward, not only because it's an important skill to learn, but it's way faster and easier to do it that way. So again, this incorporates that previous skill. Skeletal structures, again, generally only show heteroatoms, so they're really only showing the important parts of the molecule, that functional group. The last little piece here is understanding how functional groups react. Right? So heteroatoms impart polarity, right? If you saw a nitrogen or an oxygen in a Lewis structure, you'd be able to draw a bond dipole. And that bond dipole is what creates both partial negative and partial positive parts in molecules. And that's what creates our reactivity. So lots of previous skills are going to be incorporated as we think about understanding functional group properties, physical properties, as well as chemical reactivity. All right, this is the big chart that you're going to want to print out, have available. You won't be able to use it when you're taking a quiz or an exam, but it will be a great tool for you to learn these. There's also flashcards that are available up on Quizlet, available through Blackboard for you to be able to practice these named functional groups. I want to walk through how this chart works. This is what we call a decision tree. You're basically going to be asking questions about a molecule that you're looking at, and it's going to help you narrow down what functional groups are present. So it's important to note that you might have molecules that have more than one functional group. So what you're going to want to do is maybe circle what you think is a functional group in a molecule, and for each thing that you've circled, go through this decision tree to figure out what the name of that is. The more that you do this and practice this, the easier it will become. So you start up here in the top left and you just answer the question that you see in the box, yes or no, and it'll help you determine what functional group you have. So do you see any of these molecule or these parts, these 6-membered rings? If you do, you want to ask, do you have an OH attached to it? If you do, that's what we call a phenol. If it's not, it's just an aromatic group, okay? This is going to be a really important piece to look at. A C double bonded to an O. This is what's called a carbonyl group. Now note, Carbonyl is not a functional group. A carbonyl group is actually part of about 5 different functional groups. So notice, if you have this, you need to say, well, what's next door? You're largely going to have a carbon atom. And I should highlight, if you see all of these R's here, R's just represent the rest of the molecule, and they're generally a carbon atom that your functional group is attached to. So again, if we're looking at this guy, we're saying we've got that carbonyl group. So what's attached to it? And that helps us determine, is it an aldehyde? It's a hydrogen atom there. Is it a ketone? There's 2 carbons on either side of that carbonyl. Is it an amide? Because there's a nitrogen attached there. Is it a carboxylic acid? Because there's an OH group attached there. We've seen these guys before, right? We learned about those in our acid-base chapter. Or is there an oxygen bonded to another carbon? That's what we call an ester. So one of the things that can also be sort of confusing, I'm not going to go through the rest of this chart right here. Some of the things that can be confusing is that sometimes names sound pretty similar. Things like ether and esters, or amines or amides. So you want to make sure that you know the difference between those. And something else that can be a little bit confusing, I'm going to flip back here just for a second. Sometimes students will see this and they'll be like, oh, it's an alcohol. But if you go and you look right next door, there's that carbonyl, which means it's not an alcohol, it's a carboxylic acid. Same thing here. When you see this N, you might be, oh, I see an N, that's an amine. But if it's right next door to a carbonyl group, that's an amide. So we have to make sure that we're able to see all of those different pieces. All right, the last little piece here to highlight is when we have alcohols or amines, you might have the ability to think about a little bit more description with the name, whether they're primary, secondary, or tertiary groups here. So that has to do with how substituted these groups are. So let's take alcohols first, okay? And primary, secondary, and tertiary sometimes have these, looks like 1 degree, 2 degree, 3 degree symbols. That's just indicating sort of how substituted they are. So what we're looking for with alcohols is we're looking at the carbon that's attached to the OH group. And we're asking the question, how many carbons are you attached to? If you're attached to 1 other carbon, you're primary. To 2 other carbons, you're secondary. To 3 other carbons, you're tertiary. If you need to, continue to draw things as Lewis structures until you're comfortable being able to see the Lewis structure within the skeletal structure. But we want to make sure we get to the point where we can look at skeletal structures. So that's how we think about primary, secondary, tertiary alcohols. Okay, let's do the same thing with amines. Now, in this case, we're actually asking the question, how many carbons are directly attached to that nitrogen atom? So if there's 1 carbon directly attached, that's a primary amine. 2 carbons directly attached, secondary amine. 3 carbons directly attached, and that's a tertiary amine. You can actually have, because look, there's a lone pair here. If we attached another CH3 group here, we'd have a positive charge on that nitrogen atom, but this would be a quaternary amine. Now, we don't have quaternary alcohols, but you can have quaternary amines. So just kind of throwing that piece out there. So it's one other piece that you might have to label with an alcohol or an amine is the level of substitution. All right, so the last piece here is sort of a really big picture piece, but if you can get this in your brain early on as you go on to take organic chemistry, it will make the course so much easier. Chemistry happens in organic chemistry when you have things that are electron rich, we call those nucleophiles, react with things that are electron poor. Those are electrophiles. Positives and negatives like to interact with one another. We don't have 2 positives interacting. We don't have 2 negatives interacting. We've learned that already in general chemistry. So applying that to organic chemistry is going to be key to understanding functional group reactivity. So how do you identify whether something's electron rich or electron poor? We can use dipoles. Those were things that you learned how to do early on in general chemistry, right? So dipoles are really just 2 atoms that are bonded to one another, that are not carbon and hydrogen, that are different in electronegativity. The more electronegative the atom is, the more negative that's going to be. So things like nitrogen and oxygen are going to be more electron rich than the carbon atoms they're attached to. That makes amines and alcohols good nucleophiles, okay? They are electron rich. things that are electrophiles. Remember, if we were to draw a dipole on this carbonyl here, we'd draw it like this. The oxygen on that carbon-oxygen bond is going to be partially negative, but we're going to have a partial positive on the carbon of that carbonyl group. Notice I didn't say a functional group, because depending on what this A is here is going to determine, is it an amide? Is it a carboxylic acid? Is it an ester? Okay, what kind of carbonyl containing functional group do we have? But carbonyl groups are incredible electrophiles. The whole second half of organic chemistry is really thinking about I shouldn't say the whole second half, but much of the second half of organic chemistry is thinking about the chemistry of carbonyl containing compounds. That's really key as well to thinking about biological reactivity. So a really important piece to think about just very generally in terms of chemical reactivity. All right, so let's just go through and practice a couple of problems here. This is going to go pretty quickly because we're not drawing these molecules. We're just recognizing functional groups that we contain here. So I'm going to just go through with all of these first, and I'm just going to highlight where functional groups are. So again, I'm looking for pieces that are heteroatoms. Okay, so I'm going to go through and I'm just going to label all of these, and then we'll go back through and we'll name them. So I'm labeling things, and in this guy, look at that's the whole molecule there. I'm labeling things that are not carbon and hydrogen. Okay, there we have one that's a condensed structure. It's not a skeletal structure. Okay, so I've gone through and labeled those. So let's go and name them. Okay, this guy, if you want, pause for a second. Go try to look these up on that workflow, that worksheet. See if you can name these. I'll pause for a second here, and then I'm just going to go through them pretty quickly here. Naming is pretty straightforward once you know what they are. This first guy is a carboxylic acid. Okay, it's got a carbonyl that's attached to a carbon on one side and an OH group on the other. This guy might be a little bit tricky because we've got a hydrogen here that's not drawn in, wouldn't be drawn in a skeletal structure. So we've got a carbonyl connected to a carbon on one side and a hydrogen on the other side. This is an aldehyde. Next guy, we've got a carbonyl that's bonded to a carbon on one side and then an O carbon on the other. This is going to be an ester. Okay. Next guy here. It's hard to see here, but there's a hydrogen. This is only a 1 carbon molecule. Okay, that might be a question you'd see in a quiz, is how many carbon atoms or how many other kinds of atoms do we see in this molecule? So you want to be able to take a skeletal structure and see all the atoms. This is another carboxylic acid. All right, guy up on top here, we've got a carbonyl that has 2 carbons on either side. This is a ketone. Next guy, got another carboxylic acid. Another guy down here, another carboxylic acid. This is actually acetic acid. This is vinegar. Okay, if we were to draw this as a skeletal structure, this is how we draw this guy. Okay, and then we finally have our first amine. And I'm going to go ahead and highlight, this is going to be a tertiary amine. Let's identify the 3 carbon atoms that we've got attached to it. 1, 2, and 3 carbon atoms. So this is going to be a tertiary amine. All right, so we have to make sure that we know those names. So use that chart, practice with flashcards, but you're going to have to look at a chemical structure and be able to identify and name functional groups. You also want to be able to know what those functional groups are and know how to draw them. So if you had to draw a molecule that contained, for example, an ester or an amide or a ketone, that you'd be able to do that.